All right, welcome back. Welcome back to Secure the Empire. We talk about everything security, cybersecurity engineering here. So, if you're looking to get into cybersecurity engineer, my job is to just share. I'm just sharing everything I know about the field. I'm also a student of the game, so I'm just sharing everything I know, everything I'm learning. And if you're interested, make sure you subscribe. So, becoming a $140,000 per year XSOAR engineer, the 100-day roadmap. Um, you know, um, what is XSOAR? Okay, XSOAR, I guess you can call it a brand. It's a particular brand by way of the Palo Alto ecosystem. The Palo Alto ecosystem is a set of security tools that's used in enterprise environments to secure computer systems, computer environments, to secure data, to secure identity flows across organization, across you know an organization technology, right? So XOR, the SOAR in XOR stands for Security Orchestration and Automation Response, something like that. Okay, SOAR stands for Security. Let me see. Security Orchestration, Automation, and Response. Yep. All right. So XOR would be so there are different SOAR tools, and one of them, one of the most popular right now, is called XSOAR or Cortex XSOAR by the Palo Alto Networks. Okay, so it's called Palo Alto Networks Cortex XSOAR. And according to Google, it says a comprehensive security orchestration, automation, and response platform designed to manage security incidents, automate routine tasks, and reduce alert noise. So, you know, computers needs to be protected, right? Computers, networks need to be protected, and of course, data needs to be protected, right? So let me make sure I'm using the right thing here. Okay, good, perfect. All right, so the environment, companies, technology, environment, computers, network, data, applications, sessions needs to be protected, right? Everything in the OSI layer needs to be protected. So we're talking about even the physical gadgets need to be protected. So we use fingerprints to access even physical fingerprints, biometrics, and stuff like that to secure the physical aspect of technology, right? So you go for everything from physical to data, to applications, to sessions, to network, and everything else in the OSI layer, right? Hopefully, you know what that is, right? So we have to protect that. So the XOR is essentially an orchestration system that will collect alerts of incidents, from different parts of the computer ecosystem, either from the operating system, from the data interface, from the web applications, from the different ports, network ports, network, even the transport layer, right? Data in transit, data at rest. Um, collecting information that would indicate some type of compromise. Remember, we're talking about security. Okay, so that's what this is about. So XOR engineers are people who essentially design and implement XOR. Right, and remember, XOR is the particular SOAR tool that comes from Palo Alto, which is a security tooling company. Okay, so you can Google some more fundamentals about that. So let me just dive into some of the things you need to learn, that you need to learn and master over the next 100 days if you want to secure a job in this environment. Um, to be frank with you, a lot of people will claim you don't need IT type of degree, maybe math, maybe computer science, computer engineering. There's a lot of claims about that. The reality is that there are a lot of people in those fields that don't have those degrees. Okay, it's really about experience and your knowledge, being able to demonstrate your experience in an interview. That's what it comes down to. Okay, But just keep in mind, you're trying to secure an environment, similar to securing a physical environment, securing a house, securing a building, right? There are locks, there are doors that people would generally, under normal circumstances, need to use to access the inside of the building. But sometimes adversaries, like bad people, bad guys, will take advantage of that, and then, so the idea is to, especially in this time and age, is to proactively secure the environment, but also be ready to respond, which is what this is about. To respond almost instantaneously, if not instantly, because if you wait 5 minutes to respond to adversaries, that's that much time that the bad guys have to do some really bad damages, like ransomware, like taking over computers, like stealing data and things like that. All right. So with that being said, I'm going to dive into what you need to focus on. All right, here we go. All right, so I'm going to go through this document. If you're interested in this document, just send an email to supportnow@myempirepro.com. supportnow@myempirepro.com, and I'll be happy to respond with the document. All right, so let's dive into this. What do we have? All right, so we have the Cortex XSOAR playbook development and automation. You need to learn what this means. Okay, I'm going to do some overhead within the next few minutes here. I'll do some overhead explanation of what they are, but you need to understand it. You take some time to read up on this and understand this yourself. But they are actually very easy, and especially they get easier with time. The more you consume this kind of information, the easier it gets. But also the more you separate yourselves from the bottom, because the bottom is crowded. Okay. All right. So what is we're going to cover Cortex XSOAR playbook development. What is a playbook? Playbook is like a set of rules or a set of tasks that needs to be taken once there's an incident. Okay, so we'll talk about that in a second. We're also going to talk about custom integrations, so a little bit of coding. Sorry guys, if you don't like coding, so a little bit of coding that will be involved in this, but coding is no big deal. It's as simple as using your phone. Yes, I said that. It's as simple as using your phone. Again, it's like anything. You start you start from the fundamentals and you build on top of that, right? You just build blocks until you become a master. All of this, if you are diligent, it will take maybe about 100 days. Okay. Then also we're gonna talk about custom integration. We're gonna talk about Python scripting, again coding, just a little bit of coding. This one is more like integrations rather. We'll talk about that in a second. Then scripting, and then we'll talk about Linux, understanding Linux. Linux is basically the language that operating systems, like the core operating system of computers, particularly even in a cloud environment, this is the language they understand. It's closer to machine language than everything else, than click, click, click everywhere, right? So being able to understand a few commands from a fundamental standpoint, it goes a long way if you're looking to secure a role in as a XSOAR Cloud Security Engineer. All right, so let's get into this, okay? So what is XSOAR playbook development automation? Building digital recipe books. So think of it as recipe books that tell the security system exactly what to do when a threat is detected. So we call them incidents, right? So it's to collect what they call incidents of compromise, IOCs, to collect information like IP address, to go into the computer and collect the user who was using the computer at the time, IP addresses, what was the location, what device was it, and just more information, and even more information about the particular file that might have been executed. But it goes, and this particular recipe book will go and collect. So the playbook automatically follows a set of rules to investigate and fix a problem. Okay, so problem you can also maybe somewhat use as incident. Okay, all right, and imagine if every time your smoke alarm went off, a robot automatically checked the oven, called the fire department, unlocked the front door for. So giving you like a basic example of what this does, right? A playbook is like the set of instructions that tells the robot exactly which chores to do so you don't have to panic. Okay, I hope that's straightforward enough. Let me make this bigger so you can see it. All right, and why do we need this? Because responding to incidents or problems from a security standpoint in computers takes time, right? So first you get an alert, and then, well, an alert is sent first, but you have to now get the alert, right? And now you have to get up and respond to the alert and know what to do and all that kind of stuff. And if every time you have to think about what to do when you get an alert, then there's all possibilities of human error, right? So this thing called XSOAR is about automation, right? Automation reduces alert fatigue, meaning not, it's machines that can handle a lot of alerts at the same time, right? And then it ensures that security responses are consistent, they're fast and measurable, right? And it says which is critical in high stakes healthcare environment, not just healthcare, by the way. I just happen to consult in healthcare, but I use healthcare examples a lot, okay? But it's in any high stakes enterprise environment, okay? So the idea is to automate, orchestrate, and respond at machine speed, okay? So that's the quick overall of what XSOAR does. Again, if you want access to all of this, it can get you, but from a design and implementation standpoint, which is what the XSOAR engineer does, you first of all need to do some requirement gathering, right? You need to identify the manual steps currently being taken by analysts, like security analysts. They have to, depending on how small the organization is, they have to literally receive an alert, like I said, then do some investigations, IP address, check reputation, then check what devices, asset inventory, which device is it coming from. And then they have to contain the issue. They might have to block, they might have to contain a particular part of the network, right? And then they have to document. Documentation is a big part of it. Then they have to notify the stakeholders. All of this will take humans, your assumption is as good as mine. It takes them a while to figure all that out, right? But as an XSOAR engineer, you will now create a logic mapping. You create like a flowchart look-alike of how the alerts are going to be handled. So alert is received, is IP in allow list or not? Yes, no. If it's in an allow area, you close the alert, right? If it's not, you check the IP reputation and then check it's determine if it's malicious or not. Let's go back here. Where are we? Okay, we're over here. All right. So it checks if it's malicious or not. Okay. Again, we're just looking at a big picture diagram here, but this is essentially what a computer would do in an instant. All right. And then if it's not malicious, if the IP is not malicious, it checks for more information, right? So it checks the user account, what file is being executed. It enrich and then document. If it's malicious, it contains the host and then send a notification to ServiceNow, create a ticket, and all that nice stuff. All right, so the step 3 here is now you have to build a task, right? So you do this inside of what they call the Playbook designer. Okay, this is it's a user interface on the XSOAR Cortex. And it's called Playbook Designer, where you would drag and drop the automated task, right? So that describe everything we just talked about, right? So for example, what alert is going to trigger this playbook into work, right? What is going to trigger it, right? And then you have to extract indicators, right? Indicators of compromise, IOCs, right? And then to check IP reputation, which means it's going to integrate into other parts of the system to actually check the reputation of the IP, to integrate into Intel environments to check if the IP has been compromised in the past or anything like that. It can also check into external Intels. Anyway, that's beyond the scope of this conversation, but just understand that it's checking the credibility of the IP address that initiated the actions that is being considered to be a threat. It checks if it's malicious, similar to what we saw earlier on, right? IP reputation, virus total lookup, which is part of Intel. Then it gets asset, right? Get the asset. This is CMDB stands for Configuration Management Database. It's a check for information about the host. Then if there's a need, it will contain the host, okay? Then also it might send an email to CISOs, to senior managers, to senior security managers, things like that. At the same time, creating an incident report in ServiceNow or any kind of ticketing the environment uses, right? So now, again, remember we're looking at it from the standpoint of XSOAR engineer. So after the engineer designed the task building, remember we're going from logic mapping, well, requirements to logic mapping to tasks. These are things you need to learn, okay? And then, let me see here, okay. And then it goes to data mapping. So this recipe book, as we called it earlier, is collecting information. It's collecting, we call them telemetry. It's collecting a lot that contains a lot of data, IP addresses, the user information, what device, what application. It's collecting, and then it also gives it an ID, right? Then it actually has computing systems that also determines how severe the issue is, right? Sometimes it correlates that from known database, like known incident databases. Sometimes it calculates it off of some kind of risk score algorithm, right? But anyway, to collect all that information and then it will flow correctly into the playbook. But that needs to be managed, okay? That needs to be managed. The data coming in needs to be managed because it needs to be converted into a language that the XSOAR, Cortex XSOAR understands, okay? So you have to map it. You have to do classification and mapping. Classification will tell us, is this a network issue? Is this a session issue? Is this a application issue, right? What type of alert is it? Rather, let's call it alert, right? So it collates that data and then it maps it to the language, the fields that Playbook understands. So Playbook has its own variables, right? So for example, it's spelled IP address, but it comes in as alert.ip. So designing this and making sure it maps correctly before you deploy this is major, okay? That's part of your job as an XSOAR engineer. So you see, they look different. You could almost tell that it's the same thing, but machines are not as smart as humans. You need to tell it that alert.ip equals to IP address, right? So doing that is what we'll call mapping, okay? So it will also tell it the source, severity, alert ID. The next step inside of all of that is called the testing and iteration, right? You want to run the playbook in a mock environment to ensure it doesn't break. You don't want to just deploy this, because if you deploy this wrongly and then it goes to block, I'll give an example, like a device in a surgical environment where there's an actual case going on. You don't want that kind of situation, right? So you want to run this, make sure it actually runs, does what it's supposed to do, right? I mean, it's never perfect, but you just make sure it's actually doing the work. Now, it doesn't break before you send it into a production environment, right? So again, testing, you set the test inputs, you run the playbook, you review the results, you identify if there's any issues, you refine the playbook, and then you approve and deploy, okay? So these are the kind of things that will come up in an interview. These are the kind of things you need to master, okay? So what do we have here? This is the full overview picture of what the XSOAR engineer, this is what they do. It's not as complicated as you might think. It's as complicated as your willingness to get into it and master it. Take 100 days, master the skill set, and then you can be on the path to a thriving career in security, cybersecurity engineering, okay? Outcome, automated, consistent, measurable response, as opposed to a human being having to respond to these incidents manually, right? It's faster threat response, reduced alert fatigue. So as opposed to you have a security operating center, they call them the SOC, and you have analysts. You have analysts that are working in there, and each one of them have to handle alerts as they're coming in. It can become overwhelming very quickly if you don't have enough automation in place, right? Depending on how large the organization is, depending on how many devices, how many streams of data is going back and forth, sometimes between remote sites, sometimes across the world, right? So the idea is you want to reduce alert fatigue, and probably most importantly, you want to make sure that everything is documented and they're audit ready and they're measurable. You can actually see how the deployment of XSOAR into a technology environment, you can see how it has actually, you can measure how it has actually helped the operation, okay? And of course, again, for example sake, you can see how this help with a safer healthcare environment. If you're talking about fintech, it increases integrity of the technology environment as well. All right. So there you have it. That's the overall picture right there of what Cortex XSOAR Playbook Development Automation does. Now, down to the Cortex XSOAR custom integration. In order for this to work, it's going to collect information from different parts of an ecosystem, a technology ecosystem, right? Organization computer systems, right? So the idea of custom integration is to write code to help Cortex XSOAR talk to other software that doesn't have a built-in connection, right? So you have Cortex XSOAR already comes with its own, comes with a marketplace for scripts, codes, and all type of stuff you can deploy right away. But in most environments, you still have to customize things to the taste of the stakeholders, but also to align with the workflow in that environment. Workflow is very important because you cannot have a too secure system that doesn't allow them to do their job, right? So now let's get through this real quick. Let's see. So the idea of custom integration is to expand the platform's reach to include niche medical software or legacy databases. Just think about your iPhone and all the different applications that it comes with that you can install on it, right? Think about being able to expand the capability of your iPhone to become a camera. You plug it into a system and you can run a live stream, right? Just increasing the capability, right? So it expands the platform's reach, the platform meaning XSOAR, Cortex XSOAR, right? So think of this like building a special adapter plug, right? Because it needs to be able to communicate with other softwares, right? So applications communicate with other applications through application programming interface, API, but sometimes you need, sometimes physical devices will communicate with an external network, right? So sometimes you have to build custom solutions or custom integration for that. So if you have a toy that only uses round batteries, but your house only has square ones, right? You'd need to build a gadget that lets the two work together, and we'll call that adapter sometimes, right? So why? Because healthcare systems often use legacy or proprietary medical device software that big security companies don't support out of the box. Again, it can be any other organization. All right, so here we go. Cortex XSOAR has playbooks in them that's been designed, that's been deployed. It's automating the incident response, right? And it needs custom integration oftentimes to communicate with third-party systems, medical devices, lab systems, legacy databases, 50-year-old computer systems or networks, right? So creating this custom integration is a big part of the job of an XSOAR engineer. Okay, so let's talk about how to design, implement the particular workflow in that, right? The first step is what we call API analysis. You want to study the documentation of the target software. Where is the source? The third party, the source. What kind of API connection are going to be used? What's the endpoint like? What methods are going to be used to connect data from one system to the other? Get, post, or is it webhook, right? There's another one called webhook. What are the parameters that are available in the logs, in the data that's available from the other system, right? So, because again, you need to feed this information into XOR Cortex, because that's what it's going to use to determine what's the next step in logic to contain or remediate an issue or incident, right? So again, and then you use response example. So this is all part of the analysis, and then we move to step 2, which is authentication setup. Authentication setup has to do with, you have two computer systems communicating with each other, and you're trying to design a zero trust architecture environment rather. They need to identify themselves. Okay, authentication is necessary. So if you go watch my previous videos, we talked a lot about IAM, identity and access management. All right, so that if you'd watch those videos, you will understand that API keys and certificates needs to be handled. Machines have their own identity and they need to identify themselves between each other, and that needs to be signed, that needs to be certified. And you use API key, you use OAuth 2.0. These are some of the protocols that will be necessary to make the technology be able to talk to each other, right? And then secure storage, right? XSOAR vaults. XSOAR is also processing data and is also documenting data, also some logs to make the environment audit ready. So permissions and stuff like that. All right, so let's move on to step 3. Then you have to define the commands, right? You have to write codes for specific actions, right? For example, get device status, right? You don't want to be attempting to connect to a device that is not on or ready to receive or send information. So you have a small code. I'm not going to get into the detail of what that is, right? You have a small code that does that, and that sometimes needs to be customized because every device will be different. It also allows to make the technology environments, security tools or security tooling, makes it easy if you want to swap one out for the other. Maybe they say everybody's saying this is the best technology now, and you want to swap it out. When you have custom integration in place, you can also make it that much easier to swap toolings or applications for any specific part of the ecosystem. All right, so command details, you have inputs in the commands, you have arguments. Argument is another word for calculations or determining the logic, right? Arguments, it's probably more like logic, right? Determining what direction to go based on the inputs, right? And then because of the connectors, you have HTTP method and endpoint. Then you have you don't want a situation where the code has issues and then it hangs and then it keeps the system in a gridlock, right? Meaning like it's looping into each other and then it's stuck. Like the same thing you see when your computer freezes, right? You don't want that. So you want to make sure your code has error handling and retries in there. And then human readable output, so that the engineer to some extent can actually understand what's going on by looking at the output. And the output is being sent. Remember, you have to convert the third-party data into XSOAR's standard JSON format, right? I don't think I've mentioned JSON, XML, things like that, but again, these are things that you'll pick up easily over time as time goes on. But it's basically data format. The data output is formatted a certain way for computers to understand, but you need to convert that to JSON format, which is what XSOAR understands, and that's called data transformation. And then you test the integration. Okay, you verify the long-running execution stays stable, right? You don't want to press play on something that can get stuck in the middle, right? So you test it. Okay. So that's what they call long-running execution. It's going to keep going and then do over and over and over again. Because remember, the idea is to handle thousands of alerts at the same time, as opposed to a human being having to handle them one at a time. And here's what they call a testing checklist. Connectivity, you test for connectivity, you test for authentication, You test the command execution. You test that the data is actually sending the right data into XOR. And then LRE, stability, the timeout. Remember LRE? This is long running execution, right? You don't want a situation where it's timeout, because computer executions can time out, right? So you want to, in case it's a timeout, you want to create exceptions and how to handle those type of errors when they do happen. So again, error handling. And then rate limit. Sometimes when you're communicating with an API interface, you can make too many attempts within a short period of time. So you want to make sure that you prepare for a situation of rate limit that it should be handled, right? If you don't know what rate limit is, you know when the computer complains that, hey, too many inputs within the 5 minutes period, and then it blocks you out, and then you have to wait for 20 minutes. Yeah, that's called rate limits, right? So you want to be ready for such situations, because when computers communicate with computers, that can happen. Because again, they use that to secure the environment, because oftentimes adversaries will run like executions that can run like 10,000 executions within a minute, to try to hack into a system. So rate limit is designed to cut those kind of operation off. So again, output here, API requirements will come out of the API analysis. The output from authentication setup, you'll be able to set up the authorization configuration, the auth configuration. The output from command definition, you will actually get a custom command created for a special type of device. And then you have the output from this will be the normalized JSON information that will be useful for XOR, right? And then the output from integration testing is validation, right? So again, the result: reliable, secure, and maintainable integration. This part of the workflow is something that you need. It's part of things you need to master. Take 100 days. You can easily master this. All right, let's see how far we've gone. How we're doing. Great. Fantastic. All right, so now let's move on to the next thing that you need to master. Well, Python scripting, when I say master, take that with a pinch of salt, okay? You just need to know a couple of things. Well, no basic coding, right? Input, output, libraries. Think of libraries in terms of like an external capability of programming, right? Just like extra applications on your phone beyond just being able to call, right? An application that allows you to watch YouTube videos, an application that allows you to text your friends outside of the phone itself, an application that allows you to pull a report, to even do word processing on your phone, right? So you have Python scripting, which is Python is a programming language. You can pick up courses on Udemy to understand that very easily. But Python is used to automate a lot of things that would ordinarily would not be possible with Cortex XSOAR, right? So, but let's get into it, and let's get you to understand it, okay? Writing Python scripts within XSOAR to perform complex data manipulation, right? So you have all this data coming in from different places, and you need to correlate certain data with certain events, with certain the idea is there's certain known actions that adversaries will take when they're trying to hack into a system or do what bad guys would do in a computer system, right? So sometimes you have to manipulate data to determine what those things are, right? And that's why we can use Python for those complex data manipulation, custom calculations that the XOR will not ordinarily be able to do, right? Or specialized security tasks that standard playbooks can't handle. All right. In a Palo Alto network, have what they call the marketplace first and then customization next, something like that. Essentially, they have a lot of They have a lot of codes that's already ready to go, codes and capabilities ready to go out of the box. But the beauty of it is that you can also expand that if you have a security engineer that can script Python code for automating parts of it. Okay, so if playbooks are the Lego sets, Python scripting is like having a 3D printer If you need a very specific piece that doesn't exist in the box, you write a script to create exactly what you need. Okay, so it's extended capabilities again. Why? It provides surgical precision needed to parse complex medical data formats like HL7, which is what a lot of medical devices send and receive data in. Right? It's just think of it as a language, data language, and automate repetitive backend task. And this is the big picture. Cortex XSOAR, playbooks, automation incidents. The Python script is an extended part of it, right? And it basically helps you, manipulate data before it comes into XSOAR. And there's something called pre-process. You can actually pre-process data before it gets into XSOAR to help manage the cost of data storage and things like that, or data storage, or even computing CPUs. Okay, all right. So that's high level, but don't worry, it will make sense as time goes on. So you have HL7, FHIR data, legacy systems, medical devices, databases, all this data coming in. You want to manipulate them to look a certain way before it comes into Cortex XSOAR, because remember, the job of the Cortex XSOAR is to receive the incidents and determine proper response, automated and orchestrated response. Security orchestrated automated response is what SOAR is all about. All right, so let's look at how to design and implement this whole thing, right? From a standpoint of scripting, scripting Python for certain extended capabilities, right? You want to script scope. They call it script scope, and you want to define the specific input and the expected output of your small script. The input is coming in from a device looking kind of crazy, funny, right? It's not. If you already know what you're doing, you can probably see a little bit, but you understand it. You understand what this data is, but a normal person might not understand what the data is, right? So forget normal person. Even XSOAR Cortex may not understand the data, because XSOAR Cortex expects to receive the data as JSON, right, in JSON format, right, which is what you're looking at right here, the output. So your Python program needs to output what looks like this, extracted from what looks like this at the top. Okay. All right. So, and then the environment setup. So once you define what the coverage of the script is going to do, the input to the output, then you want to select the appropriate Docker image. It's called Python 3 in XSOAR. I guess there's multiples. Okay. I'm only familiar with Python 3, but there's multiple versions essentially, right? Like any other application in the world. So you want to determine which environment you want to write that in. And there's something called the Mr. Mock request pandas. What are these? These are called libraries. Okay, these are libraries that will help you do even better data manipulation. So you never really, for the most part, have to write the code from scratch. You use existing functions that are stored inside libraries to do what you want to do. Okay, and once you understand this logic, it's easy to do some of this stuff. So then you develop the code, right? Writing the script using XSOAR internal libraries, okay? And this is the code right here, okay? Again, if you want to learn Python coding, I would advise to take a small $23 course on Udemy. Error handling. You want to add try except blocks. Try except is a type of function inside of Python that allows you to validate if your code is working and not allow it to get stuck in a loop, just in case it breaks, right? So what it does is it blocks to it's a block that prevents the script from crashing the whole playbook, right? So even after writing the full code, you want to put that inside of a try except block so that there's an out or there's an exit in case the code gets stuck in the middle, right? So it says key practices: validate all inputs, use try except blocks, log meaningful errors. Okay, so try except also allow you to log the errors that happen, so you can actually do a root cause analysis and fix it, right? And then it returns a user-friendly error message. All right, so it fail gracefully. So in case the code fails, it will fail gracefully, and then it will actually keep the playbooks stable as opposed to getting it stuck. Okay, and then performance optimization. You ensure the script runs in milliseconds to maintain scalability. The idea of all of this, the idea of automation, is that even when you are scaling out a larger operations is going on, the codes are able to handle, let's say the computer, like for example, a whole location can go out of, they can go out, like they can have a blackout, and then you're receiving thousands, tens of thousands of alerts in the playbook or in the system, in the logs, right? You want the script to be able to handle itself and not burn out CPUs. There's resources to be managed. That's the point. Okay, that's the whole point of performance optimization. Okay, so you minimize API calls. Okay, these are best practices. Okay, use efficient data structures. Okay, there's some data structure that just consumes more CPU than others. Okay, you want to avoid unnecessary loops, right? You want to reduce redundancy, essentially, right? You want to leverage caching when possible. Caching is when you store information locally for easy access when possible, right? Obviously, there's certain operations where you can't do that. And then you want to test with large data sets. So there you have it. Fast scripts equals to scalable automation. How are we doing? Again, this is a video you can watch over again, over and over again. You take one piece of everything I'm saying here and you master it. You start from the fundamentals, okay? Result, precision, reliability, scalability, consistent, right? Python scripting in Cortex XSOAR delivers surgical precision for complex data and automation while maintaining the speed, reliability, and skill required in high-stakes security operations. If you see healthcare in my document, just turn it into high stake, okay? Complex data, Python script, then it makes it usable for XSOAR playbook, then automated action, and better outcomes. Good. All right, let's see how we're doing. So we've done Python scripting, so we've covered the actual development and automation, the overview. We've covered Cortex XSOAR custom integration. We've covered scripting for Cortex XSOAR, and let's see how much time we have left. Okay, all right, we've got some time. Now the next part here is it's called Linux application. Okay, as an XSOAR engineer, sometimes the clicks and the drags and the drops are not good enough, particularly when there are issues, particularly when you need to do root cause analysis of issues. So Linux, understanding Linux fundamentals will go a long way to be a very nice block you can build on over time. Linux command. Linux is again is the closest to computer language for environments like cloud and operating systems in general. So sometimes the issues are beyond just being able to click around, okay, and being able to investigate what's happening at the operating system level, right? And also when it comes to configurations in the cloud environment, Linux will be very useful. So what is Linux? Managing the underlying operating system, Linux, where XSOAR lives. Everything we're looking at right now, you're watching me on your phone, you're watching on your TV, I don't know, right? All that is surface level, user interface, UI, but there's a lot going on behind the scenes, right? So that last bit is what we call operating system. This involves configuring servers, managing files, and ensuring the engine of the platform is running smoothly, right? If XSOAR is a video game, Linux is the game console, is the motherboard, right, of a computer. You need to know how to fix the console, update the software, and make sure it doesn't overheat so the game keeps running. Yes, it can overheat. It can use too much resources, too much CPU power, all of that, right? So why should you know Linux? Why? XOR is Linux based. Understanding the operating system is vital for troubleshooting. Okay. For troubleshooting performance issues, managing disk space, right, and securing the platform itself. And here's the big picture again. You have the Cortex XSOAR. Linux is the foundation of it, right? That needs to be stable. It needs to be secure. It needs to be scalable. Okay, so you need a high performance XSOAR. And then the infrastructures, the language they understand is Linux. Okay, server, storage, network, all of that. All right, and that's what allows Cortex to be able to. And then remember that the engine of Cortex itself also resides on Linux. All right, so let's talk about how to design and implement this from a standpoint of Linux, right? Storage management. Okay, sorry, number one is not storage management, it's server hardening. You want to disable all unnecessary services to protect the operating system. You know how you buy a nice little small laptop from Best Buy or your best electronic store, and you want all the features to be working, right? When it comes to enterprise level environment, is the opposite, right? We only turn on what is needed, and we only use just what's needed, the minimum needed to get the job done, right? So you want to disable unused services. You want to remove unnecessary packages, because those things become additional potential attack surfaces for bad guys, right? So you want to turn them off. You want to enable automatic security updates, right? So that there's proper patching as this updates with the system. They want to configure SSH securely. SSH is basically access to the underlying system that manages the whole operating system. Is the this is how you access the root login. Root login is much more powerful than administrator, right? Meaning somebody can have access to this and shut the whole thing down. Okay, so that Linux is how you communicate with that part of that. Okay, understanding some Linux commands. Check running services. This is the command for check running services to disable a service, right? This is command system. CTL to mask a service, right? All right, so all of that you understand as time goes on. The goal is to reduce attack surface and secure the operating system. Exactly. So step 2 in the design phase is the storage management. You want to configure logical volume management to undo massive amounts of security logs. There's going to be lots of logs documented for compliance purposes, but also for non-repudiation purposes, right? That's a big word, but something you should get familiar with. But the idea is that you don't want somebody to tamper with the part of the system, and we need to be able to see that. It's like a camera. It's like a camera in front of your house that sees everything, but also documents everything. That's the log, right? So yes, that's what security logs are. And you want to, the architecture looks like the physical volumes, volume groups, right? For easy understanding, of course. Logical volumes, right? And then the example commands create PV, create VG, right? Remember, PV is physical volume, then you have volume groups, and then you have logical volumes, right? And the key goal, you want a scalable storage for logs, right? Because after you're getting a lot of logs coming from just regular, good old baseline operations, you want to be able to get in there and know where what is residing. You don't want to have to be digging through a bunch of information that you don't understand. So you have to keep things organized, essentially. Okay, so logs, reports, and attachment, all of that. And then 3 is permission logic. You want to set up least privileged users. So part of the zero trust principle is well, the major part of that is least privilege, right? You least privilege only access access based on what is needed to get the job done. No more than that. Okay. You only give people just enough access to get their job done. You give machines enough access to get its job done, and then you verify everything. And you want to assume that there's a breach already. Okay. So you set up least privileged users so the application can't accidentally delete system files, right? So best practices: run services with non-root users. We talked about root access earlier, SSH, right? So you want to restrict sudo access. You want to use file permission correctly, right? Some files will have certain types of access. You can write, you can read, you can do both. Sometimes you can only just view only, and sometimes you can see nothing, right? So you want separate service account for every little possible opportunity, as long as it doesn't burn up the resources. But also, that's the idea. That's the idea of zero trust, right? So you have a user, you have a group, you have a home, you have a shell, you have a purpose, right? And that's XOR service user. The key goal of this part of the implementation, the permission logic, is the key goal is least privilege access, reduce risk of damage. Okay, zero trust. Remember, zero trust. I might need to do a whole video on zero trust, but I think I've covered that in the IAM part of it, of this channel, right? Set up firewall rules, IP tables, firewall for secure communication, right? So the network is protected by firewall in general, and you want rules for access, rules from machines, from individuals, from applications. You want to set up rules for those kind of things, right? You want to set up rules around ports, 443, 8443, 22, 5672, right? All those things they sound technical right now. They will make sense as time goes on. Again, you have 100 days, so just start from the fundamentals. So the key goal is to allow trusted traffic only and block everything else. You block some, you access some, and some you give conditional access. We talked about conditional access when we were talking about multi-factor authentication, right? You block some, you allow some, and sometimes you ask for a second layer authentication. And then, of course, we want to monitor everything. We want to use Linux tools to track CPU and disk health, because without the disk, without space storage, without good performance, memory usage, nothing is going to work. Remember, this is the operating system, so you want to be proactive. Proactive visibility ensures health and performance. So if there's a spike, you're able to see that even as an alert on your SIEM environment. Okay, SIEM stands for security events. Security, what is SIEM? I know EM stands for event management, but SIEM is basically what gives you overall view to everything that's happening in your technology ecosystem. Okay, you have security information, security information and event management. Okay, all right. Okay, so we have results. It's a stable, secure, and high-performance XOR environment when you are able to get proper visibility and management of the operating system, which is Linux. Does that help? I hope that helps. If you're getting value out of this, please let me know in the comments. It's very encouraging to see comments. All right. Let's see. Okay, we're almost there. Optimizing and streamlining security processes. Let me see. What is this one? Okay, this is like a big picture of everything, really. Yeah. So let's not worry about tools. Let's just understand the logic, understand how it works, and then you can dig in deeper as time goes on. But optimizing and streamlining security process is part of your job as a everything you do on your end also help the analyst, right? How clean your designs are will help the overall operation. So what is this? Collaborating with human experts to find clutter in their daily work and using engineering to remove it. It's about making the security team faster and more efficient. That's the job of the XSOAR engineer, okay? The XSOAR Cloud Security Engineer. So it's like watching a chef in the messy kitchen and moving the salt, pepper, and pans closer to them so they can cook a meal in half the time without getting tired. How's that? Why in a hospital merger or high stakes merger, you often have two different security teams doing things two different ways. Streamlining creates a single gold standard process. So standardization is part of your process, is part of your job as an engineer, right? To keep things standard for continuity, just in case you find a better job and you go to another organization, they can actually continue operation without you. Okay? And here's the big picture. Security teams from team A, team B, but everything is streamlined through an optimized process through Cortex XSOAR. And then you have one gold standard that works for the whole organization with or without any individual persons or even team. Yeah, that's the idea, right? We want to make things standard. So let's talk about how to design and implement this workflow. If you want to do that, a lot of interviewing of stakeholders. Sit down, so your communication skills is good, right? So you shadow analysts to see where they waste time, right? You shadow analysts, you even shadow everything from CISO down to the analyst, right? Key activities: shadow analyst, ask why 5 times, document every step, capture pain points. The output, you get the current state process map. And then second step, you identify the bottleneck. Bottleneck identification. You find steps that take hours but could take seconds. Remember, the idea is to get rid of people's jobs. Well, I'm kidding. But if you know this stuff, your job is safe. Okay. Identify criteria: high manual effort, long waiting times, frequent errors, redundant checks, meaning process that could take a lot easier, but you've gone through like 40 different years to get to a place you can get to in 40 days, right? So you have data everywhere instead of in one place, and that's costing the organization a lot of money too, right? The output, you get a bottleneck report. And then you also have what we call refactoring, redesign existing playbooks to remove redundant checks. You have a clustered up playbook steps and logic, and then you clean it up to one straight streamlined line. You remove duplicate steps, automate manual tasks, standardize data looks. Doesn't it sound like fun? It sounds like fun. It's like you're playing all day, like you're playing a video game, right? You simplify the logic. You get paid for simplifying processes, right? The output is optimized playbooks. Sometimes you create even what we call sub playbooks to make this happen so that it's easy to see where the bottlenecks are. Remember that bottleneck report that we're going to get from bottleneck identification, right? So now we're at feedback loop. You implement post-incident reviews to see if the new process actually helps. Sometimes we call that post-mortem. After incidents, you find out what happened and you created an improved process to be able to handle that better in the future. All right, how are we doing? Let me see how we're doing. Okay. So post-incident review, what worked well, what didn't, what can be improved. You update the process of playbooks, right? So the output is action items and updated process. And last but not least, we have a dashboard, right? You create a visual chart to improve, to prove that mean time to respond, which is a major metrics in this type of operation, to prove that it's going down. The mean time to respond to incidents, right? You want as many as possible instant response that's actually as accurate, repeatable, consistent, scalable, right? Consistent, scalable. That's a consistent already. Scalable, right? Efficient, all of that, right? So metrics to track, you have the median time to respond, automation rate, alerts handled, incident volume, false positive rate. False positive are basically incidents that comes in, but they were not a big deal. Okay. And then you have SLA compliance. SLA stands for service level agreements, right? And then the output is executive and team dashboard. So what do we have here? We have, again, we have a faster, smarter, stronger security operations. All right, reduced MTTR, less manual work, consistent processes, higher automation, data-driven decisions. That's all I have for you on this particular one. Again, if you got some value out of this, make sure you hit the like button. Leave some comments if you have questions, anything you want me to cover into the future. I will happily bring it forward. Take care and God bless.